Hello ළමයි. Let's start our first session of MCQ discussions. හරි. එහෙනම් අපි වැඩි වටන් ඕනේ ළමයි. හරි අපේ පළවෙනි session එක MCQ discussions all right. හරි. So today we are going to discuss about the MCQs, the past paper questions appearing at the page number 16 of your workbook 1. Right? ඔයගොල්ලෝගේ history of atom workbook එකේ page number 16 වල තියෙන past paper MCQs තමයි අපි අද discuss කරන්නේ. Right? We are supposed to discuss the first 10 MCQs here with this short session. Right? Okay, let's start. The first one. Question number 1. See what it says. Nucleus charge of oxygen is. Nuclear charge of oxygen. This is the first question, right? Nuclear charge of oxygen. Right, when it comes to oxygen atom, oxygen is your 8th element. No? That means inside the nucleus of the oxygen atom, right? 8 protons are there. 8 protons are there. Right? This is the the nucleus of the oxygen atom. 8 protons, and normally when it comes to oxygen 816, 8 neutrons are also there. The charge of the nucleus is actually given by the charged species at the nucleus. Those are the protons. Right? So nuclear charge of oxygen is a charge of 8 protons. The charge of oxygen is the charge of 8 protons. Right? So what is the protonic charge? So charge of a proton is equal to +1. Is actually the relative charge. So then when it comes to actual charge, of proton, right, is going to be 1 into the smallest charge unit, that is 1.602 into the power minus 19 coulombs. So when it comes to oxygen atom, you have such 8 protons. So charge of oxygen nucleus is equal to charge of 8 protons. So 8 into charge of protons, that is 1.602 into the power minus 19. So this is the charge of 8 protons, which is going to be the charge of an oxygen nucleus. Right? Do we have such an answer? So if you are to simplify this stuff, right, it is going to be something like 1.6 into 8. Right, 1.6 into 8. So 48 is 4 to 8, no? 12.8 simply, right? Into the power minus 19 coulombs. So do we have such an answer? Right? So 1.6 no. If you are writing as 128, into 10 to the power minus 20 coulombs. Right now, so such answer is not there. So answer is none of the above. The answer is none of the above. So we can have to take the answer as answer number 5. Right. The අවශ්‍ය activity කරගන්නවා. Right. Okay, let's come up with the question number 2 then. Question number 2. The scientist who worked hard to put forward an atomic nucleus model is, right? Nuclear model. It was nuclear model. What was the experiment led to the nuclear model? Experiment led to nuclear model. That is what? Gold foil experiment. Gold foil experiment. Or one can say alpha scattering experiment. Alpha scattering experiment. Who are the scientists involved with this experiment? Rutherford, Geiger, and Marsden. Those are the 3 scientists involved with the gold foil experiment, which ultimately led to the first nuclear model. First nuclear model. Right? That is the first nuclear model. B.Sc. Remember? Electrons are here and there, and the nucleus at the center. In 1911, nuclear model was introduced by Ernest Rutherford. This is the experiment which led to the nuclear model, the gold foil experiment, and the scientists involved were Rutherford, Geiger, and Marsden. Right now, so the answer is answer number 2. Answer is answer number 2. Marsden. Right now. Okay. That is a review for the question number 2. Right. Let's come up with the question number 3. Right. The radius of an atom is in the order of, right, this is again about the Rutherford's nuclear model. right? Right? What was the ultimate observation or conclusion about the sizes of the nucleus as well as the atom? Right? The size of the nucleus, first of all, this is the nucleus, this is the atom. So the size of nucleus is in the order of 10 to the power minus 15 meters. And the size of the atom in the order of 10 to the power minus 10 meters. Right? So if you are thinking of centimeters, you're thinking of centimeters, right? This will be equal, it's like this, no? Centi means centi, or C means it is all about 10 to the power minus 2. Minus 2. Right? So we can write this thing as taking 10 to the power minus 2 out, 13 into 10 to the power minus 2 meters. So this is what? 10 to the power minus 3, this is centimeters. What about the atom? So this can be written as 10 to the power minus 8 into 10 to the power minus 2 meters. So 10 to the power minus 2 can be written as C centimeters. So in centimeters terms, the size of the nucleus, right, with 10 to the power minus 13 centimeters, and the size of the nucleus atom is with 10 to the power minus 8 centimeters, right? So we can use the same setup for the question number 4 as well. Right? The radius of an atom is in the order of 10 to the power minus 8 centimeters. So nucleus, the nucleus is it 10 to the power minus 13, centimeters, right? So the nearest answer is 10 to the minus 12, right? Nearest answer is 10 to the minus 12. So you can take it as 10 to the minus 12 for this thing, right? The nearest answer is 10 to the minus 12. Out of those answers given, we have to consider the value. So the most acceptable answer is answer number 4 for question number 4. So for question number 3, answer is answer number 4, 10 to the power minus 8 centimeters. That is the size of the atomic radius. And question number 4, looking for the size of the nuclear radius. The size of the nucleus comes with 10 to the power minus 13 centimeter cubes. So such answer is not there. The closest value is 10 to the power minus 12. So we can take like that. So that is the answer 4 again. So for the question number 3 as well as for the question number 4, the answers are with the number 4, right? Okay. So complete this thing. Right, let's copy the question number 5. Fifth question. Question number 5. See what it says. Right. The gold leaf experiment done by Rutherford using alpha particles explains that A. The atom consists of electrons. See, this is all about gold foil experiments. Right? The atom consists of electrons. No, it is not a proof by a gold foil experiment, right? So, atom consists of electrons. That idea was given by Thomson's model, Thomson's plum pudding model. This is actually before the gold foil experiment. Right? So, statement A is false. Right? Statement B. The mass of the atom is concentrated into a point and the volume of it is very small. Yes. That is referred to as the nucleus, no? So, total mass of atom is concentrated to a dense core at the center of the atom. It is called as the nucleus. That idea is proposed by gold foil experiment, right? Right? This was explained by gold foil experiment. Observations of gold foil experiment, right? So, B is true. Gold foil experiments explains that idea. C. Atom is building units of matter. No, that is actually Dalton's idea before the gold foil experiment. Atom is building unit of matter. That means atom is the fundamental particle of matter. That idea was by Dalton's gold foil model. Or one can say first introduced by Democritus and Greek philosophers. So these were came before gold foil experiment. right? So C is false. It's not an explanation, not an explanation by the Goldford experiment. D. Neutrons are found in atoms. Neutrons are found in atoms. Neutrons are found in atoms. So actually that is by James Chadwick. Neutrons. In 1932. Actually after the Goldford experiment. So Goldford experiment is carried out in 1909. Right? Right? This is after Goldford experiment, right? Years after Goldford experiment. Right? So that is also not an explanation by the Goldford experiment, right? So only B is true. Only B is true. So only B is true means answer should be answer number 5. Right? Only B true. So answer is answer number 5. So for ABCD questions like this, actually these questions coming right with at the question number 31 to 40 in your A-level paper. In your A-level paper, question number 31 to 40, these kind of ABCD questions are there. Right? Okay. So when answering these questions, the ABCD questions, right, to come up with the correct answer, you have to use this, right? So if A and B are correct, if A and B are correct, you have to mark number 1, right? If B and C are correct, you have to mark number 2. If C and D are correct, you have to mark number 3. If A and D or D and A are correct, you have to mark number 4. Right? For any other choices are correct, you have to come up with the answer number 5. That is how we comment for ABCD questions. So here only B is true. That means answer number 5. Only B is true coming under this section. Any other? Right? Answer number 5. That is the answer of the question number 5. Let's complete that step. Right. Let's see the question number 6. Question number 6. Right? Okay. See what it says. The fourth statement regarding the following statement is, so we are looking for the fourth statement, right? Every atom in an element has an equal number of electrons in each of them, right? So we are looking for fourth statement. Right? Let's call first statement. Every atom in an element has an equal number of electrons in, right, each of them. Right? Okay, that is true. This is true. Right? Right? When considering an atom, is considered right, number of electrons are equal to number of protons, right? When an element is considered all atoms are with same number of protons. Same number of protons. So same number of protons means from this thing, as number of protons are equal to number of electrons, same number of electrons as well. So when an element is considered, all atoms are with same number of electrons. So the statement says every atom in an element has an equal number of electrons in each of them. So the statement is true. Clear? When an element is considered, all atoms are with same number of electrons, as number of electrons are equal to number of protons in an atom. Right now? Okay, second statement. Every atom in an element has an equal number of neutrons. That is not going to be the same, right? That is false. Isotopes exist. Isotopes exist. What are isotopes? Isotopes are atoms of same element but with different number of neutrons. Mass number differs because number of neutrons differ. So every atom in an element has an equal number of neutrons. That statement is false, as isotopes exist. Right? Statement 3. Every atom in an element has an equal number of protons. That is true. All atoms are with same number of protons. Right? All atoms are with same number of photons, right? So The third statement is also true. This explains all atoms with same number of protons when an element is considered. Right now? Okay. For the fourth, every atom in an element has equal number of nucleons. That is also false. Why is that? What are the nucleons? Nucleons. Nucleons are the nuclear particles. Right? So, protons plus neutrons. Nucleons are the protons and neutrons. But we know with isotopes, the number of neutrons changed. Number of neutrons changed. So, number of nucleons will also be changed. So, number of nucleons also change. Right? So, every atom in an element has an equal number of nucleons. That is false. Number of nucleons will be changed. That is what isotopes do. Again, with isotopes, this statement is not true. Number 5. In an element, the atomic number is equal to the number of electrons it has in an atom. Right? The idea is, this statement is true. The idea is, atomic number is equal to number of protons. But for an atom, number of protons equal number of electrons. So that atomic number is equal to number of electrons. Instead of number of protons, you can write number of electrons. So, for an atom, this is valid. For an atom, this is valid. Atomic number equals number of electrons. But when it comes to ions, that is not true, right? When it comes to ions, you have excess of ions in negative ions, electrons, excess of electrons in negative ions, and you have lack of electrons in positive ions, right? When it comes to ions, this is not true. But when considering atoms with means elements without charges, right? So then this is true, right? So the fifth statement is also true. So we are looking for the false statement, right? So we have two false statements, no? So 2 and 4. So 2 and 4 are false statements, right? So answer, we have two answers there. 2 and 4 can be taken as answers. Right, no? So that is the review for question number 6. So let's complete this stuff. Let's discuss the question number 7. Question number 7. See what it says. The atom was first articulated to the world by, yes, out of these choices, it should be Dalton, no? Right? So, a precise description of atom is first introduced by who? John Dalton, from its golf ball model. Right? So, for the question number 7, your answer is answer number 2. The first idea of the atom is actually by Democritus and Greek philosophers, but first precise description about atom is given by John Dalton. Right? So keep that in mind as well. Right? First idea of atom or atomos is by, right, Democritus and Greek philosophers, right? Keep that in mind as well. So out of these answers appearing at the question number 7, the best choice should be Dalton, number 2. Right? No? Okay. Let's come up with the next one. Question number 8. Question number 8. See. Rutherford's gold leaf experiment revealed that, right, that means this is also again Rutherford's gold foil experiment. Gold foil experiment or gold leaf experiment, what is that? Same stuff, right? Quite a large space of matter is empty. This is true, no? Right? Is true. Right? Quite a large space of atom is empty. That is why almost all alpha particles travel through the gold foil without a deflection. Without a deviation. Right? So the statement is true. B statement. The positive charge is concentrated at nucleus. Right? The positive charge is concentrated at nucleus. B statement is also true. Right? Positive charge is concentrated at the nucleus. Concentrated at the considered as nucleus, as nucleus. Right? So that is also kind of a conclusion by the Rutherford's goal for the experiment, right? So as all the mass is concentrated to the nucleus, considered to the center of the atom, that is how a large space become empty, right? A large space of atom becomes empty as all the mass of atom is concentrated to a very small space at the center of the atom. Right now, so positive charge is considered as nucleus. That is true. Right. C statement. Only a thin layer can radiate alpha particles. Right? Actually, aluminium foil is not the one which radiates the alpha particles. Alpha particles were radiated by a radioactive source. Right? So this idea is false. Right? Thin gold foil is not the one which does radiate alpha particles. Alpha particles are radiated by a radioactive source. Radioactive source. Right? So the C statement is false. Statement D. The electrons move in quantized energy levels. Right? Statement D is false. Actually, the electrons move in quantized energy level. That idea was given by the next model, by the Niels Bohr. Right? Quantized energy level. Quantized energy levels of electrons. Idea was proposed by Niels Bohr. with his planetary model. In 1930. Right, Rutherford's goals for experiment is done in 1909, and which was experiment led to the nuclear model. In 1911, right? So the contrast individual idea was put forward by the by the Niels Bohr with his model, the planetary model, right? That is not anything proposed by the goal for experiment. What goal for an experiment done was introducing the nucleus to the atom, right now. Okay, so statements A and B are true. So A and B true. That means answer is going to be answer number 1. So this is ABCD question. So A and B true means answer number 1, right? Okay, this complete the step. Right, next one. Question number 9. Right, see the question number 9 here. Right. Okay. The mass of an electron is, right? This is the mass of an electron, right? So mass of an electron, what is the value? That is 9.1 into 10 to the power minus 31 kilograms. This is what we have learned. Do we have such answer? No, they have provided the answers in grams. They have provided the answers in grams. So kilo means, the kilo term means 10 to the power 3, yeah? Kilo means 10 to the power 3. Okay, kilo means 10 to the power 3. Instead of the letter K, simple K, we can substitute the 10 to the power 3 there. So this is going to be 9.1 into the power minus 31. Instead of K, we just write 10 to the power 3 grams. Instead of K, we just write 10 to the power 3. Right? So that is going to be 9.1 into 10 to the power minus 31, and some 3 is there, minus 28 grams. So this is the mass of an electron. 9.1 into 10 to the power minus 28 grams. So we have such answer at the answer number 3. So answer is answer number 3. Right now, that is the review for the question number 9. Okay. Let's move to the question number 10. It's simple, no? Right. Let's come up with the question number 10. Right. 10th question. See, the true statements regarding alpha particles is, right. We are looking for true statement. True statement or statements on alpha particles. Right. Statement A. Alpha particles take up electrons to make helium atoms. See, actually, what are these alpha particles? What are these alpha particles? Alpha particles equal helium nucleus. Helium nucleus means what? The helium atom is with 2 protons and 2 neutrons. So helium nucleus is also with 2 neutrons and 2 protons. When it comes to helium atom, you have some 2 electrons as well. This is the helium nucleus. So if you add some 2 electrons to there, so you will come up with 2 neutrons, 2 protons, and some 2 electrons are the electronic engineers, right? This is helium atom, right now. So alpha particles takes up electrons to form the helium atoms. So that statement can be taken as a true statement, right? This helium nucleus is the alpha particle, right? So you take 2 electrons to copy the helium atom, right? Let's complete the statement B. See what they are saying there. The penetration power of alpha particles is very small. The penetration power of alpha particles is very small. What is meant by the penetration power? Penetration power. It is all about ability to go through matter. Ability to go through matter and appear from the other side. Right? So penetration power depends on 2 things. Penetration power depends on 2 things. What are 2 things? When size is high, it is hard to go to the atomic layers. So penetration power decreases. Right? Size is related to mass, right? Size or mass. Size is related to the mass, no? Greater mass means greater size, one can say like that, no? Right? So the idea is this now. So you have atomic layers. So if you are a small particle, you can go to the spaces between atoms like this. If you are largest particle, you can't go to the spaces in between atoms. So penetration means going through this. Right? So if your size is small, that is better. So if your size is large, penetration power is less. So the second thing matters is the charge. When the charge is high, again penetration power is less. So when the charge is high, it tends to attract to the charges of the atoms. So then the rays will deviate. If your particle is with a charge, that tend to attract towards the, if let's say your particle is with negative charge, then that tend to attract towards positive nucleus of these atomic layers. So deviation would occur. So deviations would occur means directions will change and ultimately unable to go through the layers. Alright. If you are with a positive charge, it will attract to negative charges of these atoms, and deviations would occur. Deviations means change in pathway of travel. So it is hard to then go through the atomic layers. Deviate means deviate අනිත් atoms එක හැප්පෙනවනේ. මේ deviate වෙනකොට හරි අනිත් atoms එක ගිහලා හැප්පෙනවනේ. ඒකට ඔයාට it is hard to go through the atomic layers. මේ basically මේ යන්න ඕනේ. හරි දැන් ඔයා charge particle එකක් උනරොත් opposite charges වලින් attract වෙනවා right similar charges වලින් repel වෙනවා. ඒකට deviations වෙනවා. එහෙනම් deviate වෙද්දි අනික atomic layers එක හැප්පිලා ඔයාට එහා පැත්තට එන්න බැරි වෙනවා. Right now? So penetration decreases when the deviations occur. Right? Deviations will occur when your charge is high, when your charge is there. So if you are chargeless particles, no deviations. If you are the chargeless particles, right, you won't attract to the charges. So no deviations. So you can easily get penetrated. Right? That is the idea. So penetration power depends on the size as well as charge. So when it comes to alpha particles, compared to other particles like electrons as well as neutrons, even compared to protons, the alpha particles are with 2+ charge. Alpha particles are with 2+ charge. The charge is high as well as mass is also high. 2 protons and 2 neutrons are there. Mass is also high. So compared to other particles like protons, neutrons, electrons, the alpha particles are with smaller penetrating power. As the size is high, charge is high, penetration power is less for alpha particles. Right? The idea is clear. The penetration power of alpha particles is very small. That statement is true. Right? Okay. As size is high and the charge is high, penetration power is small for alpha particles. Right? Now? Okay. C statement. The ionization power of alpha particles is very small. So what about the ionization power? The ionization power. Right? Actually, that is the opposite. That is the opposite. Right? When the charge is high, it is easy to ionize matter. It is easy for you to get rid of electrons from atoms. That is ionization. Right? So ionization power means right, ability to ionize atoms. That means get rid of electrons from atom. So that depends on charge as well as size. When you are with greater size, more probability for you to hit those electrons. ඔය size එක ලොකු වෙනා නම් ළමයි ඔයාට chance එක වැඩි electron එකට හැප්පෙන්න තියෙන chance එක වැඩි. හැප්පෙන්න පුළුවන් chance එක වැඩි. නේද? වහුගක් පොඩි නන් නේද? පොඩි කෙනෙක්ට පොඩි particle එකකට electron එකක් හරි පොඩිනේ. පොඩි කෙනෙක්ට පොඩි particle එකකට හැප්පෙන්න තියෙන chance එක අඩුයි. නමුත් if you are a large one, you have more chance, right, to hit to those electrons, so that you can transfer your kinetic energy to those electrons, and after absorbing those kinetic energies, right, after absorbing that energy from your particles, right, the electrons would eject from the atom. Right? So size එක ලොකු වෙන්න more chance for the particle to hit those electrons and transfer their energy to those electrons to get ejected from the atom. Size එක වැඩි නම් ionizing power එක වැඩි. අනිත් charge එක වැඩි නම් when the charge is high, you can repel the electrons more if your negative charge is high. If your positive charge is high, you can attract electrons greatly. So both will lead to release electrons from your atoms. Atom එකේ electrons අයින් කළා දාන්න repulsions attraction දෙකම හේතු වෙනවා. Right? So the point is, in size or the mass is high, you can supply greater kinetic energy towards electrons. Ionization power is high. The other thing is when charge is high, ionization power is high. और पहले ने चार्ज එක දෙද්දි කොහොමද වැඩි වෙන්නේ කියලා. charge එකදී මෙහෙමනේ. හරි සරලව කිව්වොත්. හරි. දැන් මෙහෙම ඇටම් එකක තියෙනවා. ඔගිල කියන්නේ ඉලෙක්ට්‍රෝන එක. හරිද? දැන් ඔය පාටිකල් එක මෙහෙම යද්දි හරිද? හිතන්න මෙයා නෙගටිව් හරි පොසිටිව් පාටිකල් එකක් කි. එතන මොකද වෙන්නේ? this electron will get attracted to the particle. Particle attract වෙනවා. particle යද්දි electron එක attract වෙනවා. So it will be ultimately ejected from the atom. The particle එකට positive particle එකට electron attract වෙනවා. Then will be ejected from the atom. Or if it's a negative particle, still the same. ඉතින් වගේ නිමුදිය ඉලෙක්ට්‍රෝන එකක් ඉන්නවා. ඔන්න මේ වෙන පාටිකල් එක. negative particle එක කියන්නේ. මොකද this electron, negative particle electron will repel from the, that thing will repel from the charge. So again it will be released from the atom. Ionization. So when the charge is greater, repulsions and attractions will occur greatly, so that this is to release your charges, release your electrons, right? So ionization power means that, right? So ionization power of alpha particles are high. Ionization power of alpha particles are high as the size is high as well as the charge is high. 2 plus charge is there, size එකත් වැඩි. It compared to electrons, protons, neutrons stuff, right? Alpha particles are with greater charge as well as greater mass. So ionization power is high. So they are saying the ionization power is low, that is false. Ionization power of alpha particles are very high. right? Okay, final stuff. Antiviyasi. Alpha particles move towards north pole in a magnetic field. That is false. Right? Alpha particle is a positively charged particle. Alpha is +2 charged. It means positively charged particle. So in a magnetic field, deviate not towards any of the poles, but perpendicular magnetic field. In magnetic field, deviate perpendicular to the field, to the magnetic field. Right now? So charged particles won't attract towards any of the poles of your magnetic field. They will just deviate perpendicular to the magnetic field. That is what we have learned with the cathode ray experiments as well as positive ray experiments. Charged particles will deviate towards the oppositely charged terminal of electric fields. But when it comes to magnetic fields, they will deviate perpendicular to the magnetic field. The idea is clear, right? Just complete this stuff. Okay, so let's wind up from here. Right? So this is all about the first 10 MCQs appeared in your page number 16 of your workbook, right? History of atom workbook, right? Just complete this stuff, right? We'll meet with another session soon to discuss the question number 11 to 20. Until then, goodbye.